So the goal here now is to turn this into a function. So I'm going to start off with function, right? In these brackets here is typically going to be our output, and then equals. Then we want the name of our function. Let's just call it exp. Now, before we move forward, I want to remind you all of something else that's really important here, and that is whenever you create a function, this name that you put here needs to be the same name as the file here. So I need to go in here and I need to hit save as. I'm going to save this as exp. Okay. So yeah, that part, if just that one part is wrong, we won't be able to use this function. Okay. Now the next thing is we would like to say, you know, what are the inputs going to be here, right? Well, we'd like to input x. We would also like to input some desired stopping criteria, so we'll call that ES. Okay. And so for now, those will be our inputs. And we'll think about maybe some outputs here in a little bit. Let's just start off with that. So I'm going to get rid of this comment here. And now, when we go to use this function, it's going to be our choice what x we plug in, so we don't need to define x up here anymore. And again, no matter what value of e to the x we are computing, technically that first term of the Taylor series is going to be 1. So we can leave that. EA and ES are still going to be the same thing, and maybe we'll just note up here one of our outputs will be EA. But of course, there's going to be more outputs that we want than that. Let's keep going here, though. So we actually also, again, are going to input what ES is, so we don't want to define it in the function. Okay. And we will need a stopping criterion, and it might be a good idea to just say that something to start with might be ES plus 1, because that will ensure that EA is larger than ES, so that way the while loop does in fact run. We'll still want that first value for I to be 1. That way we're doing x to the 1 over 1 factorial. For our next term, we want to put in a few more outputs here. Okay. So maybe I'll write in here approximation of, I'm going to say of, how about just capital E and then XP. There we go. I like that. Okay. So that's going to be one of our outputs is this approximation. I'll change this a little bit down here. I just wanted it to be a little shorter for our function so that it's not looking too messy up there. So approximation of EXP. Okay. So that looks good. Okay. Our number of iterations, how about we just call that IT? For short. And maybe our last output EA here, maybe we'll just leave it like this. Let's go ahead and run that. Okay. Looks like everything's suppressed. And I said let's run it, but one thing I did mention the other day is you can't run a function. We just need to save it, and we can then use the function. So how about we try to find e to the 1 here. Okay. Okay, and it looks like we ran into an issue. Okay, we don't have enough input arguments. Okay, because remember, I'm supposed to actually input more than just x. I also want to input the desired accuracy really here. So 1 comma, and let's just do that there again. Okay. All right, so it is running. Let me scoot this up a little bit. Okay, and so we can see that we have our approximation here, our number of iterations, the error, and then we actually have this thing here, which has been another output. Okay. So I want us to make a few small edits here and address this extra answer here. Okay, so we chose to make sure that every time we run this function that it displays these three things. Okay, but by default it's always going to display this first output here, and so it's just displaying it a second time. But there's another approach that we can take here in writing our function if we don't like looking at all that. Okay, so here's the idea. We could actually go in and, so EA is already an output anyway, so I really don't need to include that there, and it's already defined up there. But like IT, we hadn't defined what that was until this very last line, but I'm going to go ahead and suppress it. And this right here, I'm going to go ahead and suppress it too. Okay. And now if I were to save this, okay, again, you will see, let me actually write this in here. Oop. You'll see that all that's displayed when this time around, there it is just that very first input. Even though we haven't made it to where our function automatically spits out these values, and by these values I mean our other two outputs, we can still make them do that. And here's how you can do it. Okay, you can actually use I'm going to just copy and paste this right here because this is what I really want. Here we go. And so I'm going to change x to 1. We could change it to some other value. We don't always have to be evaluating e to the 1 here. And I'm going to put in our threshold there. But if I do this, okay, it's going to give me all three of these outputs when I use this function now. Okay. Let me scroll up so we can actually see it. Okay. There it is. Okay. We have our approximation. We have our absolute relative error and number of iterations. Okay, and we don't actually have to make these outputs the exact same variable as up here. I could actually maybe say approximation of E or EXP. I could say absolute relative error, or I could use, you know, variables that are a few less letters. We don't need all these letters in here, but I could actually write this in here, number of iterations, and it'll still run. But do keep in mind that these do need to be in order. It's going to give me these three outputs in this order. So if I were to mix up one of these three down here, we would run into some issues, but we should be fine here. We're gonna go ahead and hit enter here in a second once I put in the correct inputs. Okay, and there it is. It still ran. Looks great. And so yeah, we built a nice function here to approximate e to you know, varying powers. And again, you can check this using some you know, other powers. We could maybe try e to the 3, and we could compare this to the built-in function. Okay. All right, and it looks like we're doing pretty good. And if we wanted this to be accurate to more decimal places, all we'd have to do is make ES smaller.